Hey, how's it going? This video is just to look at a few of the changes that have been made in version 1.3 of the RUBE Box2D editor. And there weren't really a lot of changes to do with actually editing the scene in this update. Most of them have been responses to requests that have come up in the forums. So they've ended up being mostly things that are just usability improvements. And a few extra things like limiting properties that get exported and so on. So, starting from the simplest things first again, the simplest thing I can think of here is that now we can move the splitter up and down so that you can get a good look at what's coming out in the script log results section of the script panel there. When you have a lot of output, it could be a little bit more convenient. Next thing we have is when we have selected a body like this, we will see in here, we see the mass of the body here as a first class property of the body. This is not really the way Box2D works, because the mass of a body is determined by the density of the fixtures it has. So this body here, we can see we have two fixtures, one on the left and one on the right, and when we've selected the body, we can see this little blue cross here. That's the center of mass of this body. And the reason that the center of mass is not in the center is because the body on the right is actually twice as dense. Sorry, the fixture on the right is twice as dense as the fixture on the left. And if I just go back to my script panel for a second, I've got a little script here that prints out the densities of each of these two fixtures here. That's just to save me having to mouse over and check them all the time. So when I run that script, we'll see here this changes. So what actually happens when you change the mass of a body is that this is going to change the density of all the fixtures in the body, and it will change them equally so that the center of mass doesn't move anywhere. So if I said let's say I wanted this body to actually be say 11.5, a mass of 11.5 for some reason. So I can set that there. Oh, okay, I forgot about this. There's a little note there just to remind you of what I'm telling you right now. I knew that. And then if we run my little script again to show me what the densities of those fixtures turned out to be, we can see that the center of mass hasn't gone anywhere, and the densities have been scaled up equally. So we can check that. I should have done this first, I suppose, but we can check that when this runs, that yes, the fixture on the right is definitely heavier. And you thought this was just a smiley face, didn't you? Oh, come on now, this is serious business. Haven't got time to play around with smiley faces. Okay. Next thing is a few little things to make editing the collision bits, the category bits and the mask bits of collision filters are pretty confusing sometimes, especially when you're making something like this where you have a lot of things overlapping and some of them you don't want to overlap or collide with each other. And when I was making this, I really wanted to have this feature, so I ended up making it. This wasn't actually a response to a request, unless you count my requests as requests. So what happens here in this feature is when you're in fixture edit mode, we can see there's an extra button now at the bottom of the property panel, and when I click on that, we can see we have each individual bit plane can be given a name. So I don't know, base, what are those things called? Tappets or whatever. So you can name the bit planes of those, and then when you have a fixture selected, you will see in here these cells are colored dark blue, and that's going to be dark blue if that bit is set. for that bit plane in that fixture filter. So that's pretty complicated thing to try and explain, but if you've used Box2D a little bit, you'll probably know what I'm talking about, I hope. So the filter category bits here is 1, which is just the first bit of the category bits. Mask bits of 65535, that's every bit of a 16-bit number. So we can see here in the right hand column the mask is set to everything, so that's going to collide with everything in the scene, except for things that have the mask set so that they don't collide with this one. It's getting even more confusing now, isn't it? But the point is, it's a little bit easier to see and set these things by clicking on this these cells in the table. And you'll also notice that when I move the mouse into these two columns of the table, we can see in the scene here that most of the fixtures are faded out. So that's letting us know that this fixture that I have selected here, this one single fixture, we can see which fixtures it's going to collide with right now. And you can see as I change this, we get instant feedback in the scene visually to tell us which other fixtures in the scene that this fixture I've selected can collide with. I hope that makes sense. It's a tricky thing to understand at the best of times, so I hope this little feature here is going to help with that. And looking into the future a little bit, I've actually made it so that you can have 32-bit collision masks and category bits and mask bits can be made up to 32 bits in length. And if you try and change these ones, the program will remind you that by default Box2D only uses 16-bit values for these. So if you want to actually make use of these extra 16 bits at the top here, then you're going to have to do something with your program to make sure your program is going to be able to understand what these mean. Yep. Okay, so another thing we can do, so hang on, if we have a bunch of fixtures selected, that's a bit too many, let's select a couple here. Okay, so we've got 2 fixtures selected now. In this case, when the mouse moves into these 2 columns, the fixtures in the scene don't change. That only happens when you have just one single fixture selected. So what we can see that's a bit different here when we have 2 fixtures selected is the cells for which the bits are set in both of these fixtures will stay as the dark purple, dark blue, and the cells for which one of them is set and one of them is not set will become sort of a faded purple, and where they're not, both of them are not set, will remain white. So that just lets you know that there's multiple values for these 2 fixtures here, and we can still set them the same as like that, and of course undo everything. Okay, now along the same lines as what we just saw there, we can also, when we're in fixture edit mode, we can hold down F, and then we can move the mouse over a fixture to see what that fixture will be able to collide with. So this is another way you can quickly check if you have your collision filter settings working correctly. And a good example of when this would have been helpful when I was making this engine is these little things here. So I can quickly confirm by holding down F here that the tip of this cam will hit this tappet here only, but the tip of this one will be the opposite way around. It'll hit this cam only, this tappet only, and not that one. So that's how we get this behavior like this. So this cam tip will hit the tappet on the left but not the one on the right, and vice versa. So it's pretty tricky, but hopefully this sort of feature where you can just mouse over any fixture and see quickly what it's going to collide with will be quite helpful. And this also takes into account when things are connected by joints, because by default a joint connecting two bodies will cause all their fixtures to not collide with each other. So it takes into account that as well. Alright, another thing we can do in fixture edit mode, which would have been helpful for me when I was making this engine again, is we can hold down the D key like that, and this will show us the relative densities of all of the fixtures in the scene. All of the fixtures that are currently in the view at the moment. And the way it displays them is that the most dense fixture in the view will be white. So that's the one at the bottom here, this large circle. It's not the heaviest, not the heaviest one, mind you. It's just the one with the highest density, which happens to be the heaviest one as well in this case, because it's large. And you can see that they're fading out until we get to these ones out here, which are quite light, quite low density. And the display will change a bit as we move that heavy fixture off the bottom of the view. We'll see that when it goes out of view, the colors for these densities change so that we can get a better range of color. So in this case we can see that the main body of the engine here is the most dense part of the scene that we're actually looking at the moment. So this is just done to get a better range of color, instead of keeping all of these ones here as roughly the same sort of pale color that they were when we saw them in the full scene. So that's a quick way to check how the densities of fixtures relate to each other, because when you're making complex structures of things that have to move around, the weight of the bodies relative to each other is quite important. Okay, so that's enough of fixture edit mode. Let's check out what we can do with the scene settings. And there's a couple of things we can do with scene settings. Let's see. Actually, we'll go to the main options for the whole program as a whole first. In the Files tab here, we have added a little section that lets us say how many backup files we want to keep for scene files and script log files, and where we want to place them. This was a request on the forums, and the reason for this is that by default when you save a file, a RUBE file, so for example we can see we have some RUBE files here in the sample scenes folder, and we've been working on a few of them here because they've made these folders here for the backups pop up. And if we look in the folders here, we can see a few script log files, and there's one backup for the RUBE file itself in there. And until now they've just been piling up forever, and that's kind of inconvenient sometimes, and it's also a little bit messy to have these folders sort of magically appearing all the time and wherever you have your RUBE file. So these options here just let you keep the number of files to a minimum, and they do that by deleting the old ones, so just be aware of that. And we can also specify a backup folder location if we want to make those files go all together in one place, because most of the time we don't really need to look at them. So that's that option there. Okay, now let's go to the scene settings, and here we have the export options tab, and the section at the bottom here is new, included properties. This is another request which came up pretty early on, and this lets you say that you don't really need to export all of those properties to the JSON file, because sometimes you just don't need them. And a good example is these ones here for OpenGL. These are kind of specific to OpenGL. If you're using DirectX or something else, you probably don't care about them. And even if you're using OpenGL, you might not care about them because you might have some other way to draw sprites and so on. So you could just turn those off and they won't be exported. And this is saved for each scene, of course. And you can go into each of these sections and say this is another one that you might not need to, the mass data for properties. So you can get quite specific about what you want and what you don't want, and you can turn them all off and on as a tree as well. Okay, next one we have over here is this thing called system hooks, and what this does is it allows you to automatically run a system command after exporting each time. So the system command can be anything that you would run in the terminal on Linux or Mac, or the command prompt on Windows, and it will run after every export if you have this checkbox enabled. And just as a quick example, actually I might go over to this other project. I think. Okay. So just as an example, we can try something like this. This will, I'm running on Linux here, so this will just print out the contents of the directory, that the current working directory, and we can set what we want the current working directory to be. And I could type in a absolute path like this to choose it, or I could browse, of course. And another thing we can do is we can use these macros here to automatically replace part of this path with something dynamically at the time of exporting. So for example, we could set the working directory to be the folder containing the exported file. So we choose this and we put our cursor in here and click insert, and that will put in this funny macro here, and when we mouse over this field we can see what that's going to become when we export, at least what it was last time in this case, because this is the export directory and that's not going to be decided until we actually export the file somewhere. But for this example I'm just going to export it to the same place I did last time, which was home Chris temp, and the command is just ls, just to tell us what the contents of that folder is. So I'll set those settings like that, and I'll just open the log panel here, and we'll export this scene, and I'll export it to home Chris temp. And just before I export, just have a quick look at what we have in this folder here, just 6 things there, and I'm going to export it to this file and save. So when I click this here, the program is going to run that system command that we set earlier. So I click save, replace, yes, and we can see in the system, the message log panel here, we started the system command and that was the command, and we can see it actually returns to you the output of that command. You can't really do anything else with this other than just look at it in the message log, but sometimes it can be handy just to check that the command is worked correctly. So we can see here we just used ls to see what was in that folder. So most of the time I think you would be using this to do copying, so you might want to do something like copy everything in, oh actually yes, that's a good one. So you might want to start in the the folder that you exported the JSON to, and you might want to copy everything to some other location, to where you're publishing it or something. And as a nice example of something that's really useful, and one of the main reasons I wanted to have this feature myself, let's skip over here. I've been doing a bit of work with Cocos2D lately, and I'm looking at my Mac here using VNC to look at the Mac over the network. So I have running here the joint types scene, and it's running in the iPhone simulator. And what I want to do here is replace the file that the iPhone simulator is using. When I click reload, it's a little bit choppy because it's sending all this information, all this video over the network, so never mind that. But what I want to do is replace the file that the iPhone simulator is using to load this scene from my Linux PC over the network, and then just click reload and have my changes reflected on here immediately. So one way you can do that is find out what folder the simulator is using, and you can do that by I'll go into the details of this in another video later, specifically for Cocos2D. But when you're reading the file, you'll be using the full path of the file that you get from CC file utils. So what I've done here is, before I open the JSON file in my iPhone app, I'm just printing out what the path for it is, and then we can see that down here. The full path is users Crystal library applications blah blah blah, and there's this huge big path name. But basically you need to figure out what that path is, and then if we come back to Linux, and I have this scene here that we just saw running in the iOS simulator, and for this particular scene I have set up the system hook to use SCP, Secure Copy Protocol, and that's going to copy the export file, the JSON file that I export, and it's going to copy it to this server, or this computer on the network, and that's my Mac. And then I'm going to put it in that folder. I'm going to directly overwrite the file that's in the folder there that the iOS simulator is using. Okay, and let's see how that works. I was going to say something else. What was it? Oh yeah. In order to do this without having to specify a password, you need to set up your Mac so that you can use SCP without using a password. And I'll just direct you to a great page. It's pretty easy actually, and it'll take less than 5 minutes, and just Google for this phrase here, pass on passwords, and probably Google will bring up this page for you, and this guy explains it. It's really easy. Alright, okay, so we have this system hook set up. Okay, so what were we doing over here? Okay, we have our iPhone and reload. So what can we do here? Okay, we just have one little box falling down here. Let's duplicate that a few times. That's this box. Let's make a whole bunch of them. Okay, now we have 17 boxes, and I'll just hit, I think I can quick export this because I did it before, so I'm just going to hit Shift Space to quick export this. Oh, okay, I didn't. I'll just export it to here. Replace. Okay, now we can see in the message log that we ran that scp command to copy this to the Mac over the network, and then if I go to the Mac to check that and reload, now we have 16 boxes in our scene. And the point is that we didn't even have to stop the iPhone app. All we do is reload the JSON file. And of course we can undo everything. Let's make this one really big or something. Let's make a funky shape like that. Okay, now we have a funky shape. Quick export, jump over to the Mac, reload. Now we have a funky shape, and we can do that all day long, and we don't get stressed out by having to wait for the program to compile or anything. There we go. So that's one of the great benefits of this system hooks setup here. Okay, so one other thing that has been added or included with version 1.3 of the RUBE editor is this whole project here using Cocos2D. So a lot of people in the Cocos2D world have been wanting to, have a sample code to show how this can be loaded and used with Cocos2D. So I'm not really going to go into the details here, but I will make another video explaining how to set up the bare bones, the very most basic things you need to get RUBE and Cocos2D running together. And just for now in this video I will go over, we'll just take a quick look at each of these 5 demos that we have in the Cocos2D RUBE demo. And it's kind of awkward to demonstrate this using the mouse on the simulator, especially using it over the network. So what I will do is I'll just cut this video here and I will show you this running on the iPad. Okay, this is the RUBE scene sample loader demo for Cocos2D, and I have it running on an iPad 1 here. And we'll just have a quick look at each of these scenes. Basic load. This just loads the Box2D world in with no images, and we override the touches began, touches ended, and touches moved methods to allow us to drag things around in the world. And this is just the joints, joint types scene, so we can play around with the joints here. We have a motor joint, weld joint. Notice we're drawing the mouse joint as well. Revolute joint, distance joint, friction joint, wheel joint, prismatic joint, and rope joint. And so of course we can zoom in on things like this as well. So yeah, so it's very basic. The focus of this is really just getting the coordinates correct, and having a nice conversion between screen coordinates and physics world coordinates, just to make sure that the rest of everything else that builds on this is going to work correctly. There we go. Anyway, so building on this, as I said, we have some other things. Images load is basically what we just did, plus images, and we can drag things around in here as well, and zoom in and out. Destroy bodies. I noticed that people sort of seem to get stuck on removing bodies from the Box2D world sometimes, and what this demo does, this part of the demo does, is instead of being able to drag bodies around, if the touch is on a dynamic body, we just remove that body from the world like this. So it's just a quick demo of that. Pop, pop, pop. Okay, pinball. Look at this. Isn't that beautiful? Let's put this in portrait. Reload it. This was actually made by a friend of mine, Trygve. I think that's how you pronounce that. And he was probably one of the first people to start using RUBE way back, like almost 2 years ago now, I guess. And this is one thing he made, and he has very kindly put the RUBE file and all the source code for this on GitHub. So if you want to check that out, I'll put a link in the description so you can go and find it. And I mentioned to him that I'd be making a video for not a video, sorry. I'd mentioned that I'd be making some demos for v1.3, and I thought I'd use this one because it was already out there, and I didn't have to make it myself, basically. And when I said that to him, he sort of unleashed his creative side and put together this delightful background for the pinball table as well. Isn't it beautiful? So, no, not my art. Anyway, we can play pinball here and hit the ball around as you do with pinball. And because this is extending the same classes that we were just looking at, we can also still pan and zoom, and we can pull the ball around like this to cheat, and sort of it's quite handy to test out the little features like we have here. Check that everything's working alright. And this demo is actually a little bit complex because we have these certain parts of the table where the ball can cross over and under different areas. So notice when we come around here that the ball goes under the turquoise path, but when we come over here and pull it up through here, it goes over the top of the turquoise path. So this demonstrates how to do things like that. Anyway, and the last one, if we go back to landscape, is the Planet Cute files again by Daniel Cook. And this is just a little platform game to demonstrate a few things that are common in platform games, like movement, jumping, detecting when you can jump, following the player with the camera, what else? Oh, picking up things like that. And yeah, it's just a little simple little scene here with some interesting physics objects in it. So that's about it. Download the source code, build it, and give it a try. Okay, see you later.